Hello viewers, welcome to Big Boy Physics, and today's video is a problem solving session. I have picked up this problem from Work by Energy Checker Understanding of Pathfinder, which is question number 9. So pause the video, give it a try for 2 to 3 minutes. So let's get started. So the version says a portion of floor in a laboratory is made frictionless. A homogeneous bar of length L is equal to 1 meter is placed on a frictionless portion perpendicular its boundary is being dragged by pulling it with the help of a light spring of force constant K is equal to 4 Newton per meter. The pulling agent drags the entire bar out of the frictionless portion by performing a minimum work, which is equal to W min, that is 17.5 joules. So you have to tell me the energy lost as heat in this cooling process. Can you tell me what is the heat which will be produced? Now the heat is produced. What we do in case of physics, that we generally write it as maximum heat produced. I don't know they have written it like heat produced, but we generally refer it as maximum heat produced. Heat is equal to work done by friction. So this is the heat produced, or we also write heat, maximum heat which can be produced as a mechanical energy initial minus mechanical energy final. So this is the heat produced. Now to do this problem, first we need to find the work done by friction, right? What will be the work done by friction? If you see that when the bar is at a distance x from the frictionless boundary, that is at a distance x, and I displace it by dx, then what will be the work done? Dw is equals to mu mg x by L into dx. If you integrate it, this work done dw's, then with a negative sign because friction is doing negative work, so 0 to L, you will get the value to be mu mg L by 2, and this is equal to heat loss, which is Q. I hope you get it. Because I already mentioned that the maximum heat produced can be written as the work done by friction if no other dissipative forces are working like drag, all those, or you can also write it as a mechanical energy initial minus mechanical energy final. Both of are correct. So till now we have already derived the heat produced. Is that the answer? No, because they didn't give us the parameters of mass, gravitational acceleration g, though we can put it as 10 meter per second square. We don't know mu and m, but they have given us something that is minimum work which is required to pull the block out of the frictionless portion is 17.5 joules. Now can you tell me that what will be the final potential energy of the spring? Final potential energy of the spring can be written as F square by 2m 2k, where F is the force exerted by the spring. Now in the final state, what will occur is basically this is my frictionless boundary. Here mu is equals to 0 and here mu is equals to mu. Here's the block completely dragged out of the frictionless portion, and the force F is getting applied with the spring. So this spring will get stretched so that this block just tends to slip. When you tend to just pull the block, your tendency is just to move very infinitesimally small distance displacements, so that each step of the process is at equilibrium. So similarly, when the end step is at equilibrium, can you tell me the force? Force will be mu mg. That's it. So you can say that mu mg can be written as 2q by L, right? So what will be the final potential energy of the spring? It will be 4q square by L square into 2k. You'll get it to be 2q square by kl square, right? Yeah, so we already found the total uh, potential energy of the spring. Now what is heat loss? Heat loss is given as final difference between the final and initial mechanical energy, that is MEI minus MEF. Now, can you tell me what is the work done? Work done will be change in mechanical energy plus heat produced or dissipated in terms of sound, heat, whatever you say, energy, dissipated energy. Here we are only considering the dissipation due to heat loss. Thus, I can say W min is equals to initial mechanical energy is 0, but final mechanical energy is what? Final mechanical energy is 2q square by kl square. Now you may wonder why initial mechanical energy is 0. Because when you are trying to pull the block at the initial stage, the force required will be negligible because the block is completely on the frictionless side. So initial will be 0, final will be 2q square by L plus q. From here you will get 2q square plus kl square q minus kl square w min is equals to 0. So you can say q is equals to minus kl square plus under root kl square whole square plus 4 into 2 into kl square w min by 2 into 2 by Sridharacharya formula. Well, you will get a plus minus, but since we are considering the magnitude of q here, since we already assumed that q is lost and we took a positive sign, so we'll keep a positive sign here. So yeah, that will be the final answer, that is L under root k square L square plus 8 k w min. 1 minute, just taking out L square in common, we'll get k w min minus k L square by 4. If you substitute the value, L is equals to 1, K is equals to 4, 4 into 4 is 16, plus 8 into 4 into 17.5, minus what is K L square? 4 by 4. 17.5 into 4 is 70, 70 into 8 is 560, so you'll get 24 minus 4 by 4, which will end up to 25 joules. So thus, in the whole process, the loss in total loss in the form of heat energy is 5 joules, and that's the answer. So today's video is this much. In next videos, I'll be bringing up more problems on the loss of energy due to friction, and if both the surfaces are moving with respect to each other, then what will be the loss. All those I'll be discussing in some other videos. That's it for today. Thank you and have a nice day.